First of all, I want to show you a little animation I made yesterday and using Khan Academy. Oops. Khan Academy is one of the several tools available now for teaching students and young students and even kids how to program. And they can build computer animation like this one in very few time, in a very short time. But my presentation today will deal with platform provided by Carnegie Mellon University. You may know it. Its name is Alice. It's also a platform for developing computer animations, only that it works in three dimensions. I mean, you can create animations with models in 3D, and you can work with left, right, up, down, front and backward. So I will start. Okay, this is a work we have been conducting, a program, a research program we have been conducting for several years now, using tools like Khan Academy, for example, what I mentioned, Scratch, and recently, and mostly in the recent years, we have been using Alice from Carnegie Mellon. This is a joint collaboration between the University Francisco Marroquín in Guatemala and the University de Colima in Mexico. My research partner, Laura Zanelli, is in the right here. What we are going to present is the result of several years conducting workshops on computer animation. This started like in 2006. We had this initiative to provide the students, middle school students and also teachers with new tools to teach students computational thinking. Valentina did a great job before me to explain what computational thinking is, so thank you, Valentina. And why we need computational thinking in our students. That was your team in the last presentation, so thank you very much. So if in Europe they need students to learn computational thinking, we do very much more here in Central America and Latin America. So we have been conducting these free workshops for students and teachers for several years, and what I'm going to present is the result of those of the experience of those years. First, I'm going to present three ideas to refocus the way we teach computer science and computational thinking in schools. If we are going to switch to teach computer animation instead of computer programming, we have to keep in mind that we are actually teaching computer programming at the same time, and we are also teaching computer animation, computational thinking, at the same time. But it's not just a matter of changing the name of a course. When we started these workshops, we decided to use the name computer animation instead of computer programming because teachers were already teaching computer programming. So we were not going to repeat what they said, but what we were were innovative in using was using these tools, these platforms like Alice, Scratch, Khan Academy. And so if we are going to change the name, we also have to change the focus. And if you think of it, our children and young people in Latin America is exposed to computer animations several times a day. They browse the web and they find animations there. They play video games and they use computer animation there. They see movies and they see computer animation there. So it seems that they may feel more attracted to computer animations than to computer programming. So it was just the right strategy for us. So it is not just changing the name, it has to be a change of the contents and attitude also. In fact, what we propose is the second idea I'm going to present is that we should change from teaching programming structures to animation patterns. And in the traditional programming courses, we teach structures like if, then, else, loops, and variable definitions, and algorithms implementations. But when we are teaching computer animation, we should switch to something else. This is what we call animation pattern. An animation pattern is a technique to build a complete scene in an animation made by computers. And we have developed a short catalog, non-exhaustive yet. We hope to advance it further in the future, of animation patterns in order to provide professors with a list of animation patterns that they can teach through all the semester or through all the year. And keep in mind that when you teach an animation pattern, you're actually providing an excellent opportunity, a contextual opportunity for students to practice programming structures. So programming animation, computer animations is just the excuse in order to teach programming structures just with more context and in an environment that they feel more connected with. As Valentina explained in the previous talk, computational thinking deals with abstract thinking, with abstraction and the application of a single solution to several situations. But sometimes this is very hard for students. They don't connect with this abstraction. So they need something concrete to apply these programming structures. What we are suggesting is that computer animation is the right context for them to learn these programming structures, just that they think they are learning computer animation. And the third idea is that this is not just an excuse to teach computational thinking. What we are teaching to them when we teach computer animation is skills that they are going to use in the future. First of all, because we all are surrounded by computers now. We are going to interact with computers very much in the near future, and our kids and young people is going to interact with them a lot more. So if they are going to relate that much with computers, they need to understand what computers, how computers think. They need to be able to talk to computers. So this is one powerful reason to learn to program. But also, we have found that these tools, even though they are directed to kids, for example, Scratch or Alice to young people, or Khan Academy to introductory programming courses, the skills they learn are very useful when they move, for example, to the computer animation industry. So they can apply what they learn in the early years of their life in a future career as computer animators. So these are the three ideas we have. And well, what we have found through the years teaching these computer animation workshops, and we have presented these results in other places, but I'm going to make a short resume now, is that when young people or when people in general engage with one of these platforms for computer animation, they adopt one of 4 styles. And this is very important because as teachers, we have to be ready for the style the students are going to adopt. The first style is instruction followers. We have noticed that almost half of the participants in computer animation workshops try to follow the instructions of the instructor even when they are instructed to just do whatever they want. When they are saying, okay, you have free time, do whatever you want, they try to improve their animation in order to make it look more and more like the one the professor presented. So you will have like half of the students in that situation. And one thing we found is that as the age of the participants increases, then the number of instruction followers also increases. So people, for example, above 30 years will mostly follow this style. They will be instruction followers. They will try to copy what the instructor presents in the class. Then the second style is what we call scene designers. Scene designers they don't feel much attracted to animation as a tool. They feel more attracted to art, to something like they try to use, for example, Alice to compose wonderful sceneries, and they bring a lot of elements into the scene and try to make it look beautiful. Okay, we don't have to force them into programming. We can show them tools. For example, in Alice, you can take the camera by programming instructions and rotate the camera and take a look from different angles, and they like that. So we have to let them interact with the platform in the style they want. And eventually, they will move to other styles. And well, one important thing about these styles is that there is no ideal style. We have to let them choose the style they want. The third style is very popular among women, among girls. They like to create dialogues, and they like to tell stories through dialogues. And usually, what you will find if you adopt one of these platforms and start teaching computer animation, you will find that they will laugh very loud when they create these stories through dialogues. They enjoy it very much. They put a lot of instructions of say and think and say and think and say and say, and they keep letting characters talk between them, and they enjoy it a lot. So this is one thing we have to let the students do. And the fourth style we have identified is what we call the Action Animator. There are some people, especially young people, they have something like a natural ability to create animations. You start teaching them Alice, showing them the basic idea of Alice, and suddenly they start creating things, wonderful things with a lot of actions, with a lot of elements, acting, and they like to show their animations to other people, and they like to help others. So one thing we have to be prepared for is that if we adopt the computer animation approach instead of the traditional computer programming approach, we're going to see these styles in the people, in the participants, in the students. And we have to be prepared to foster them into those styles. And we have to be prepared to animate them into moving between the different styles. One thing I was thinking while I was hearing Valentina in the last talk is that we should do contests, not only for programming or solving problems through algorithms, but also for designing wonderful scenes or creating dialogues or things where these all other styles of interaction, of engagement with the platforms may also flourish. So this is basically our approach. The three ideas we discuss is how computer animation can be used as a vehicle for teaching computational thinking. When we are teaching computer animation, we are also teaching computer programming. How we should move shift the focus from teaching programming structures to teaching animation patterns, and also that this is not a waste of time. People is going to use this knowledge in the future. So thank you very much. If you have any questions, I will be very glad to answer them.